I'll do my best to struggle through. Yeah, I want to show you my observatory now. So it's tell me, show me. There are no spectra wiggly lines in this talk. It's all to do with the practical side of things. So yesterday David showed pictures of the Hugginses and you saw more or less the same pictures yesterday of the observatory, which was in South London in the late 1800s. The building no longer exists, and they were a double act. William and Margaret. She was very helpful with all the observations. So take you back on a journey to 2013 when I moved from London to 35 miles east of London in the county of Essex, which is where the observatory is situated, and started to get it built then. But I was looking, what am I going to call this observatory? The observatory needs a name, like a call sign, a unique identifier. So I was always a fan of William Huggins, and so I just decided to call it, at that time, the Huggins Spectroscopic Observatory. Why not? And there is no other Huggins Spectroscopic Observatory, so it's a unique identifier. And Huggins was an amateur astronomer active from about 1860 to around 1905 or so. He died in 1910. His wife died in 1915. And to my knowledge, please correct me if I'm wrong, he produced the first amateur atlas of stellar spectra. And I kind of followed in his footsteps, and I have to do a plug of my book, a spectroscopic atlas of bright stars, published by Springer, New York, USA, by me, Jack Martin, and this was published in 2010, 10 years of imaging and 2 years to write. And at that time, as far as I know, it was the second amateur atlas of its kind. So that's the book plug over with. So let's get on to the observatory. Right, so this is the observatory. There are actually two observatories. The one behind it, that's for visual. So I've got a 4-inch Takahashi refractor in there, and I use that for visual. And when people come over, they can use the telescope. But this is where all the science is done. It's a roll-off roof observatory, and not a dome. And the reason for a roll-off roof is because you can see the whole sky. With a dome, you have to keep moving it, you have to rotate it round the sky as the telescope moves round. So this was a more practical solution. So we went with the roll-off roof. So what's inside the observatory? Well, there's the rig. And I'm going to go through it bit by bit, detail by detail. I use a Paramount MX. And it takes 6 counterweights, and I've got 5 counterweights there. So it's pretty, with the payload that it's got on it, it's pretty close to the limit of what you can add on. I think the payload for the MX is 45 pounds or 100 kilos. That's pretty close to that. The telescope, when it's been running since 2013, and I started off with a Celestron C11, and I was using that for like 2-3 years, and then a C14, Celestron C14, an old fast star telescope came up for sale. So I decided to buy it because it came in at quite a good price. So we installed the C14, and the C11 went into the other observatory and was used for visual. Now, two things about the C14 and the C11. The C11 has a wider field of view. The C14 has a narrower field of view, which can be problematic when you're trying to find an object. But the trade-off with this is that you're getting a bit more light, a light for your money, a bigger bang for your buck, but the law of diminishing returns applies. So because I'm doing spectroscopy, it's all about getting the light. I'm not doing planetary imaging or deep sky imaging, I'm doing spectroscopy, and it's the light that I'm after. So the bigger the aperture, the better. And that's really working at the limit of the actual setup itself. And the observatory is 8 foot by 8 foot square. There are 2 computer screens. There's no eyepieces. Well, there is one eyepiece for the Finder telescope that I'll show you. But so when I'm actually doing an observing run, we've got, maybe it is easier to use this. Yeah. So there are 2 screens running. This is the monitor looking at the target through the 4-inch Finder telescope. So I can actually, and it's updated every 0.4 of a second, so I can actually see the target. And this is runs. You look at the software with this. So I'm using 3 computers, and I'll tell you why I'm using 3 computers. And the software that I'm using to do the spectroscopy with is any desk is a piece of software, what that means is you can operate the computer remotely from upstairs. So sometimes I use it, sometimes I don't, and it's all hardwired in. But it's just a remote control piece of software, and it works quite well. And I've tried various pieces of software over the years for controlling the mount remotely. I think there was one called Type VNC was the first one we used, and that was just full of problems. And then there was Team something or other, I can't remember what, and I overstayed my welcome on that, and they just throw you off if you use too much time on and you don't pay for it. But any desk works fine and it's free. Dimension 4 is a program that is used to keep very accurate time, and you can use that anywhere in the world, and it connects to an atomic clock. In this case, University of London computing section. Whether they have an atomic clock or not, I'm not sure. But the atomic clock that I know is the one at the National Physical Laboratory in Teddington in southwest London. They have atomic clocks there, and maybe they feed off of that. And then good old Maxim DL, which I've been happily using for years. It's I find it a very stable piece of software, and it works, and it rarely gives problems. And then we have the PhD2 guiding. That's a piece of freeware, and that really has come along. It's really well developed now, and there's a version 13 come out very recently, and the computer automatically updates when they put a new version out. Now the thing about PhD2 guiding is that it's very friendly to spectroscopy. Why is it friendly to spectroscopy? Because it has a built-in slit, and it works very well, and I've been happily using that for years. When I first started out, I was using PhD1, and then they got PhD2 out, and there's a forum, and you can go on and you can ask questions, and they'll get back to you. So that works well. Now the SPOX module software. What is a SPOX module? Well, it's a piece of kit, a piece of electronic box of tricks that Sheljak bought out a few years ago. And what that does is allows you to take calibration and flat frames at the press of a button, and you'll see the way it's connected up in a minute. And the SkyX Pro software, BISC software for controlling the telescope, for pointing the telescope. The telescope is the most important part of the kit, because if you can't point at the object, you're not going to get any spectra. So that's what you should be spending most of your money on, a really good quality mount. And the operating systems, when I first started out, I was running on Windows XP, and then that went, and there Windows 7 and Windows 10 operating systems. Hardware, right. Well, you've got the Celestron C14 and the Dew Shield. You've got the Bresser AR 102mm refractor, which is the telescope that looks at the targets. 3 cameras, Starlight Express 694825 and the Lodestar, and they're all mono CCD cameras, as I'm sure you know. For spectroscopy we don't use colour. I was using Attic cameras, but I decided to change over to Starlight Express because I wanted backup cameras. So the Attic cameras are sort of retired, but they're there as backups. And the Lyres 3, which is the business end, which gets the spectra. It's a litro high-resolution spectrograph design, litro design, designed by one Otto von Littrow, who was Austrian, sadly died young. This would have been about 1860. Von Littrow's father and grandfathers were the directors of the Vienna Observatory. And I've got all 6 gratings. I've got the 150, 300, 600, 1200, 1800, 2400 line to the millimetre gratings. And what that means is I can work from low resolution, which is about 718, right up to about 18,000, maybe 19,000 on a good night. And those figures are based on Sheljak tests. So I can do single line spectroscopy, look at a particular line, hydrogen alpha, hydrogen beta, helium, or with the lower resolution gratings, such as the 1200, I can look at maybe 3 or 4 lines of interest, depending on what it is, the particular project. Now, the collimating lens, I'll show you in a minute, is motorised. They don't come standard as motorised. You have to make that modification yourself. But mine is a simple modification. I'll show that to you. I've got the Spox module there as well, and the Moonlight focuser. That's an American focuser. And the Kendrick dew controller and the heater bands, which you cannot get Kendrick kit anymore. He got out of the business a few years ago, but they do work very well, and I'm pleased with that. And the computers and the backups. Now, the reason for the backups is that it's always the computers that give the trouble, that break down, that have issues with. The reason for that is that the computers are sat in the observatory all year round, right through the 4 seasons, and they're operating in the winter nights. They're not designed to operate outside, whatever computer you've got. So eventually they will succumb to the elements, and I'm starting to use smaller and smaller computers. So there's 3 computers running at any one time. So there's actually 6 computers in there, 3 are backups just in case one goes down. And this does happen. And the KVM switches as well, so I can switch from computer to computer and see what's going on. And the Deco TP link, which is a piece of hardware which is hardwired to a NAS drive, a mirrored drive as well, so that means it's got 2 disks into the house, and an uninterruptible power supply in case of a power outage that will run for up to an hour, and that's just a series of batteries. It's a backup battery. And the Lindy USB cables are gold plated, and they are the ones to go for. They are really high quality cables, and they're not expensive, but when using cable lengths, you should not go more than 3 meters because in length, because then you will come up against problems that. Okay, so look, you can see the computers there. They're quite big, but what I'm doing now is switching to, as I replace the computers, I'm using smaller computers. There's a mini Mac, and that's partitioned to run on Windows 10. That's an HP mini business machine, i5 processor, Windows 10. Some of these are Windows 7. The good thing about these machines, these type of big desktops, is that when they break down, you can repair them easily because you just take the covers off, take it and run it into the computer shop. The guy tests it. You need more RAM. You need a power supply, and he's got a whole stock of stuff. But they are aging, and I'm going to be replacing them. There's one up there. That's the one that died recently. But I've now got another one of these machines to replace that. So it gradually getting smaller and smaller, and they do take up quite a bit of space. Now, so we've got one computer controlling the telescope, running the SkyX and PhD2 guiding. I've got another second computer, and that runs Maxim DL, and that is connected to the camera, and that downloads the images, the spectra. And the third computer controls the camera on the 4-inch refractor. I was advised some years ago that to have everything running on one computer is not a good idea. You get a conflict of software, and I was told just run these programs separately, because the SkyX doesn't like certain programs and other programs. There can be a conflict, and also if it's easy to make a mistake and press the wrong button and the whole thing can crash. So if something goes wrong with the electronic finder telescope on the target, that goes down for whatever reason, it's not an issue because you're already on target and those computers are working away at getting the data. That's why it's on separate computers. Right, this is the deco drive, which is hardwired into the house, and that's the internet, and that transmits all the data that comes down through the camera, which goes directly into the house, into the NAS drive, and that is it's hardwired. Dug a little trench into the observatory, and that runs through. It was, I don't know if you can see it in this one. No, it was not long after I got the cabling up and running. I put some protect around it, and it was attacked one night, probably by a fox. And it just ripped through the outer protector, but fortunately didn't manage the cable. Didn't bite through the cable, which is like a 25-foot long Ethernet 6 cable. That would have given me a problem because you can't repair those. You've got to rerun a whole new cable. So you do get animals running in, entering, coming into the garden in the early hours of the morning, and there really isn't anything you can do about that. But I've only had the one issue. Oh, so that's the D-Link NAS drive there. So that's what all the data is downloaded onto that, and it's backed up onto 4 other hard drives, so that if a hard drive goes down, I've got plenty of backups. So far that's proved reliable. I haven't had any issues with that, and that's plugged into the Deco link, and that's the router down there. And behind there, although you can't see it, I've got fibre optic internet, which is the fastest internet that BT, British Telecom, provide. So it's all fibre optics, which means you've got a faster download speed and a faster upload speed. And I've just got the basic package, but you can get even faster upload and download speeds, but they're quite expensive. But for what I do, I don't need it. Now, why has the screen gone blank? Okay, there we go. So this gives you a sort of close-up look at the computers, the newer computers, and the way it's all wired in there. And you can spend, I spent quite a bit of time routing wires and trying to keep it as tidy as possible. There are a lot of wires, well, there will be with all those computers. They're all connected, and so if one computer goes down, all I have to do is switch on the other computer and plug the camera or what have you into it. These are the KVM switches. So I got I can run 4 computers on one KVM switch, but I'm only in reality looking at 2 computers. They're there for backups. The 2 switches on the left are there for the backup computers, so they'll kick in if one of the computers goes down. And this is the newer type of KVM switch, and that's for the 2 computers, and that's connected to the 4-inch refractor, which is the electronic finder scope. Okay, so that's the pier that the Paramount sits on, and you've got the power supply to the Paramount. And there is the power supplies to the cameras, and there's, although you can't see it because it's round here, that's the connection to the joystick that you get with the mount, which means Paramount give you a joystick and you can control the telescope with that if you like. The pier is bolted into the concrete base, and that was a little bit of a hit and miss because we took measurements and we were hoping that it was pointing towards Polaris. If that was bolted in and cemented and it wasn't pointed into Polaris, that means the whole lot would have to be ripped out and start again, and I'd have to pay the builder twice to do it. This was professionally installed, by the way. I didn't do it myself, but we took a few measurements, and it turned out okay. That's the Kendrick Dew controller, the Digifire 12, and that runs 3 Dew bands. I've got the pictures that I can show you. That's you can't actually see where they're plugged in, but that's been working away nicely for years. There is now an English company that make called Dew Control that make their own Dew controllers and Dew shields. So if that goes down, all I've got to do is make a quick phone call or send an email, and there'll be a replacement on the way. But I also have a backup Dew controller as well. So okay, so I said there was an eyepiece in the system. So what this is there's the Starlight Express camera there that looks at the target, and occasionally there's a flip mirror in there, just an ordinary flip mirror. That's all you need. You don't need to spend £300-400 on a top quality flip mirror. That is 1 1/4 inch, by the way, and that's a 25mm Celestron Plössl eyepiece. And occasionally, if there is some difficulty finding the target, I have to revert to the old-fashioned way of doing things and use my brain and my Mark 1 eyeball to actually find the target. And over the years, you become, you get to know the object and the star fields in which it lies and the colour of the star, and you can actually see the targets and recognise the target by its magnitude and colour, and because it all comes with experience. So that's just a backup method of finding things. We recently completed the T-point model. That was the subject of a lot of preparation. So now that I've got a reliable T-point model, don't need to use that so much, although I still have to look at the target. And the idea is that the target is in the centre of both screens, but I need to do a bit of tweaking of the refractor to get it lined up with the main telescope. But so far so good. Okay, so this is the hardware that controls the that Spock box, the Shellac Spock's box is that controls your flat and calibration images, and this is the Moonlight focuser control that focuses the telescope, and this is a Skywatcher motor focuser, and this focuses the collimating lens in the low-res spectrograph in and out, backwards and forwards. Why have I got this set up? Because you should not disturb the spectrograph, which is pretty sensitive for other reasons, at all. You should leave the spectrograph alone, and you see why you leave the spectrograph alone in a minute, because that can cause all sorts of problems. The biggest problem you can have with the spectrograph is that it can fiddling with the spectrograph, you can throw the star off the slit. Very easily done. So at least this way, with these remote controls of focusing and flattened calibration lamps, you don't disturb it at all. There's the what do they call that? The TP link. So everything is wired into the internet and into the main router. And so there's six Ethernet cables connected to each of the computers, and one Ethernet cable that runs down to the router where it picks up the internet from in the main house at the deco link there. So I don't like Wi-Fi because it's unreliable. It's proved to be unreliable in the past. Everything is hardwired in and it works. Now, the spectrograph. This is a film changing bag. I used to do photography in the old house, and I had a dark room and everything, and that's where the film changing bag came from. The Li-Res is not light tight, and there's two things you can do about that. You can put it in a bag to keep the light out, and there's two reasons for doing that. It also keeps the dust and all the particulates in the air, because the air is polluted, and there's particulates that we breathe in, and if you leave the you see it, the dust in the atmosphere settle on the telescope equipment, and you end up having to clean it off if you like to keep it clean. It's not good for the optics, and these spectrographs and the kit is not cheap, so it's best to keep it in as good condition as possible. So that serves two purposes. It keeps the dust in the atmosphere out, and it keeps the Li-Res light tight. One of the members of the astronomy club that I belong to wanted to make some sort of box for me to put that in to keep it stabilised, because it's unstable for temperature changes throughout the night. The collimating lens can go out of focus. That can be a headache because that affects the science, but I've managed to fix that now by being able to refocus the collimating lens remotely using a motor attached to the Li-Res, which I'll show you in a few slides down. That's the uninterruptible power supply. It's a bank of batteries. So what that means is if you get a power outage, that will kick in and keep it running for up to an hour or so. That's where all the cables, the sockets, there's like a six to 8 plug sockets in that box, and all the equipment is plugged into that, and that just keeps it out of the elements. You shouldn't have wires exposed, and the wiring was done professionally by a friend of mine who's an electrician by profession, and he used the IC25 standard boxes which have covers on them, so you can close those down and seal in the sockets. The electrics are pretty much sealed in and were installed professionally. Okay, so there we are. There's the rig set up in all its glory. So there's the 4-inch refractor finder scope. There's the C14. There's the Kendrick dew controller. There are actually 2 dew bands, not 1, 2 dew bands on the C14 to keep it from dewing over during the winter, because in the winter, it's not so much the cold that is the issue. It never really gets, might get a few, maybe 5 degrees below zero in the winter, maybe 10. If we get in that's a sort of considered a cold winter in the UK. And it's quite happy operating at those low temperatures. It's the dew in the atmosphere that's the enemy. That is what causes the real issues. You can get very damp nights in the winter, and that is a problem. That's why I've got that big dew shield up there. By and large, it prevents the corrector plate from dewing up, and sometimes that telescope is running all night, depending on the project that we're doing at the moment. And I find November the best month really, because you can do a 12-hour run. You can set up at 5 o'clock in the afternoon. By 5:30, it's dark enough. Off you go until 5 o'clock the next morning, which means you can go to bed and leave it running all night. The only problem with that is there's only one downside, and that is at some point you have to do a meridian flip with that paramount, and it could mean setting the alarm for 1 o'clock in the morning and getting up to do that. Although you can do the meridian flip an hour and a half before it's actually due. So 11:30 at night, do it, then go to bed and get up and then view the results in the morning. Now, I was talking to you about Lindy cables. These are gold-plated cables. They are premium quality cables, and they're not expensive. And I've converted over to them, and I've found them to be very reliable. And that is what I advise people to go for the gold-plated cables. And the cheaper cables are not as reliable, so you only have to spend out once on those cables, and they will work for years and years and years, and they're a good investment. The moonlight focuser. Well, there was a bit of an issue with that to begin with, because it came originally with small bearings, so they broke after a while, and I had no focuser. The bearings just could not take the payload of the camera and the spectrograph, the cameras and the spectrograph. So I was very, very lucky with that, because I had a friend who actually had a spare moonlight focuser doing nothing. So he let me borrow it. So what I did was I took the old moonlight focuser out with the broken bearings, sent it off to the USA, and had the upgrade done to the bigger bearings, and there was a very fast turnaround on that. Moonlight were very good, very excellent service, and the whole thing took a week or so, and it was flown over by UPS courier on a Thursday, and it arrived on a Friday. Within 24 hours, I had that back in my hands, ready to install. But I've got the second moonlight focuser as a spare backup, just in case. And you can get upgrade kits for the bearings for those. And that's the other side of the moonlight focuser, and that has a tendency to cause slippage if the telescope is pointing up at the zenith. So you have to tighten that so that doesn't happen. You have to keep an eye on it, because if it slips, it goes out of focus. But by and large, it works pretty well. Okay, so look, this is the business end of the telescope. Now, I told you about the Spock's box. I had the spectrograph converted some years ago by Olivier Thizzy, who some of you will no doubt know, when he was over, when Shelyak used to have a stall at Astrofest, UK European Astrofest in London every February, and I said I need to get the upgrade done, and so you get the neon and the flat lamp switches put in, and you get another guide module put in, and he just took it back to the hotel that he was staying at down the road from Astrofest and did it for me overnight on a Friday night, and I went back there on Saturday, all done. As I said, I converted over to the Starlight Express cameras. That's the Lodestar guide camera, and that's the newer one, and it's more sensitive by one extra magnitude. They've upped the sensitivity of it, and when you're doing fainter stars, I do stars. That's my speciality. That's pretty. It means you can go down and magnitude. You can go down a magnitude, and it does actually make a difference. That's the most sensitive monochrome, the 825 that they have, and that is the fan that does the cooling, and as far as I know, they're manufactured in Britain, but the English climate being what it is, they're really well built for that particular climate, so they work well. There is some people motorise the micrometer on these Lyreses. I've seen a few overkills done on that, and I've had discussions with people in the UK and America, and we came to the conclusion that it's not a good idea to motorise that. Why? Because you're putting stress on the micrometer, and that can cause the micrometer to wear out, premature wear to the micrometer. But it's up to if that's what someone wants to do, fine. But we just decided not to go ahead with that. But collimating, the focusing, the collimator is more important. Okay, so it means you have to turn that by hand, which is not a big deal. I've mentioned that the Lyres was not light tight. Well, the answer to that is this tape, this pliable washi tape, which you can get on Amazon. And in my town, there's a post office that actually sells stationery and sells this tape. So I can just walk in there and get a roll of tape. I don't even have to order it off Amazon. And they do it in all different colours for decorative purposes, but you want the black one, and it's very pliable and it's quite long lasting, and it does the trick. The Lyres is made mainly of aluminium, anodised aluminium. And over the years, I've collected all of the 6 Lyres gratings. So I've got the 150, the 300, 600, 1800, 2400, and the one that isn't in there is the one that's being used, in this case the 1200. these gratings now come in at €700 a throw. But they're worth the investment, because what that means is you've got the versatility. Depending on what you want to look at, what you want to do, you can do multi-line spectroscopy with these, and then you can do single line. You can look at single lines in higher resolution with the 1800 and 2400 gratings. So I bought the Li-Res around 2009, and it was the most versatile piece of kit, and I believe it still is. But they've got the UVEX and other models out now that so it's moved on, but it's done very well. I should be going. Here we are. Okay, so this is the motorisation. Now, I'm very fortunate indeed, because I have a metal worker, also an amateur astronomer, photographer, just down the road from me, and he's got his metal workshop and lathes and all sorts, everything that a metal worker would have in his garage, and that's what he does. And he will make you up most things, but they're bespoke in that I need a bracket to fit onto the Li-Res, and he'll come round and he'll measure up and he'll make you a bracket out of aluminium. So there's also a very good supplier of nuts and bolts and all sorts of things of that nature, called Group Components, that are in North London, and you can just walk into there and you can get any type of stainless, anodized nuts, bolts, any threads and the washers in any quantity. There's no minimum order. You can just walk in there and I say, yeah, I need 2 bolts and 2 washers and 2 nuts, and yep, they'll supply it. And that's the cabling for the Spock's box, and that runs on a belt. And there's the other side of it with the motor, and that's the pulley that I had manufactured at the metal workshop down the road, and it really is. It really works well. There was a predecessor to this that slipped and did not work well at all, but we decided that we were going to make it work. We wanted to keep it simple, and there are other versions of this going around, and they're more sophisticated, and you need a degree in electrical engineering to figure out how to work it, but this is just my philosophy. Look, is keep it simple, and what that means is if anything breaks down, it's easy to replace. And I've got spare motors, and I've got the spare control boxes as well. And there's a guy at my local astronomy club who does all sorts of electronic repairs. He dabbles in everything electronics. So if you get a breakdown of the control boxes, I'll just ship it into him, and usually he can do some sort of repair, or he orders the spare parts and does everything. And he also does soldering as well, which is a bit of a dying art these days, because everything is throwaway. I don't believe in throwing things away when they're repairable. So that's the other side of the collimating lens, and you can see there's the belt there, and there's there's another belt inside round the collimating lens, so it engages with the teeth. So the two belts rotate and turn the collimating lens backwards and forwards. But what's very important is that these adjusters have to be loosened off, otherwise it won't work. So they're loose all the time. Okay. Now another issue with these Schmidt Cassegrains, it's finally dropped, is that they tend to suffer from something called mirror flop. And what that means is, as the telescope is going round the sky, the mirror can flop about. It's a common fault on these Schmidt Cassegrains. So the way out of that is to go to your nuts and bolts company and get the right threaded bolts and wing nuts, and what you do is you insert them there and you tighten them gently, very gently, and you lock the base plate of the mirror, and that prevents the mirror flop. So the actual technique for doing that is that you point the telescope at the sky, so it's pointing upright. So, and then you go round it with a ruler or something, a long shank screwdriver, and you just tap it, tap all the way round, and that allows the mirror to settle horizontally. Gentle tapping, you don't bash it. And then you gently tighten these up, and it's all done by feel, and then you lock it with the wing nuts, and then, hey presto, as if by magic, that gets rid of the mirror flop. So what this shows all the three cameras that have been, they're about a year old, 18 months old. They've been working for 18 months. And yeah, they've been, I have to say, they've been very reliable. They're CCD cameras, not CMOS cameras. Starlight Express are developing a CMOS camera, but I was brought up with CCD cameras, and it's what I do and it's what I know, and they work for me. I know they're being phased out, and I know CMOS is the cameras to go to, but there's been some issues with CMOS cameras, amp glow being one of the issues, but they work very well, and they continue to be supported. So most of the people I know in our small telescope science group are using CCD cameras, but a few of them have gone over to CMOS. But that's another learning curve, as I understand it. Getting pictures with CMOS cameras is a different procedure to getting pictures with CCD cameras. Okay, so there's the C14. Now, it's strapped to the Versa plate of the paramount, because some years ago the bolts on the other side that tighten the Versa plate to the dovetail worked loose, and I was unaware of that. I just sort of noticed one night something was rocking, and it turned out to be the telescope. The other, so we managed to fix that. The danger there is, and this actually happened to someone with a sort of similar rig. He pointed the telescope to the zenith, didn't realise that the locking bolts on the other side of the Versa plate had worked loose, and the telescope started slipping off the Versa plate. but he managed to catch it just in time. So that sort of these prevent them. That can prevent that from happening. They're good quality straps from a hardware store, and they don't get loose because of the nylon material that they're made of. Now, the observatory came with a south-facing shutter. So if I'm looking at an object, I mainly got it for the planets actually. So that's facing south. So that shutter will drop. And if you happen to be looking at a star, like for example in the constellation of Lepus, which is low down below Canis Major, which is low down in the UK, Sirius is low down in the UK, you can actually get a few degrees down to look at an object nearer the horizon, so that's very useful. But that came as an optional extra. The chains did not come as an optional extra. I put them on myself, so what happens is it just goes at an angle of about 110 degrees once it's opened, whereas before it would be a real problem, and it's quite heavy. It would just drop 180 degrees, and then you have to go out of the observatory and physically lift it up, and it's quite heavy. And I put that strap on there so that I can just physically drop it from inside and bring it back up, and that works quite well. What I found was I had to do quite a few modifications to this observatory and a few replacements of the bits and pieces over the years. One of the things that I added was the cover, a little handle to the cover. It really makes all the difference because you just pull it off and push it on. Push, easy, rather than grip it round and push it on like that. And the thing about that is that I've got a couple of hooks on the observatory wall, and that just sits on the observatory wall out the way. It's just tidy and it's convenient, and it works well. Just an aluminium handle, drill a couple of holes, bolt it through, and it's easy to get on and off. And there it is, sitting on the hooks in the observatory wall, out of the way. And it's little things like that make it easier. Those are the counterweights. As I said, I'm close to the limit of the payload. It will actually take 6 counterweights, but I'm not going to add anything else to it. So there's no need to buy another counterweight. Last time I checked the price, they were about £250 each, not weight, cost of those counterweights. I can't remember how much they actually weigh, 20 kilos or something like that. I can't remember. They're stainless steel, and you can see over the years the way the design has changed at Software Bisque with the way these counterweights are designed, but by and large it's telling me my time is up. Yeah, they work really well and they don't rust. There is a need, unfortunately, for pest control. You get all sorts of insects coming into the observatory. I've had spiders get into inside the telescope, but we've managed to get them out. And I heard a good method of keeping them out was to put chestnuts around the telescope. And I've been told that they don't like the the smell, the scent, something puts them off, spiders. And because it's damp in the observatory, you only get them at certain times of year. They like the damp environment. And the other thing to do is to put a dehumidifier in, but energy prices have gone through the roof, so I've decided not to go down that road. So we just use the rat traps to trap any insects that decide to invade, and they're changed every 6 months. Unfortunately, there is a need to do it because it's all exposed to the elements, and insects will come in and make it their home. The floor was a problem to begin with because I decided to put rubber mats down in the beginning. It was all rubber mats, and that was a disaster because on damp nights you'd get condensation running down from the walls. All the 4 walls would be affected, and the water would seep under the rubber mats. And we all know what happens when water and wood come into contact. Bad news. So I decided not a good idea. So I took all the rubber mats out and just kept the floor as is. But the wood needs to breathe. That's the most important thing, and it's fine now. The observatory needs to be ventilated, otherwise you will get a mould problem. And I had the carpenter come in a couple of years ago, cut out the slots and put in the ventilation grills, and that works quite well. A few years ago, I had to replace the roof because it was leaking. It was made of the same slats. That was the roof, a slatted roof. It just went to pieces and started leaking onto the telescope if you had a storm. So I got the carpenter in, and he got sheets of marine grade plywood, which was quite expensive, and he installed that and he refelted the roof. And there's been no issues since then because the plywood was cut into 4 sections, 2 sections either side of the apex. So although they're because it's too heavy to put one piece of ply up there because it's quite thick, and it's, as I said, it's marine grade, what you use on boats, and that increased the weight of the roof, but that's okay. It still works to prevent them from messing on the rafters. That works well. So you have got pests coming in to the observatory and outside the observatory as well. That backs onto the railway line, and there's a lot of bird life at the back there because of the trees, and you've got quite a few species of birds, but it was the pigeons that were the most problematic. The magpies don't really come near it for whatever reason. The base is about a 4-ton concrete base, 4 tons of concrete, which is what it sits on. So it's a very stable setup. And when the trains go by, not an issue. I've actually filmed it with a glass of water sitting on there when the trains come by. I have a film at home, and I'll show this sometimes because the question you get asked is, don't you get an issue with vibration from the railway line? No. And I filmed it with a glass of water, train going by, and there was no vibration that could be seen in the glass of water. So it's a very stable structure in that sense. These are the ferrite rings that you put into the cables of the cameras Starlight Express recommend you use those to prevent any interference. They come with the cameras. There was a lock on the door, but the lock broke. And the lock came from a department store that has now gone out of business. So anyway, I decided not to replace it, but there's never been any issues with locks at all with people coming in, because they can't access it because they have to negotiate the railway line, and they're not going to want to be run over by a train. But I've never had an issue. Just a take-home thought on the subject of light. This is all about light, remember? And here's your take-home slide. We are the only species to extend our day using artificial light, and that has consequences for everything living on this planet, including nocturnal species. 50% of animal species are nocturnal. And now we've got the LED lamps that the council has installed to save money, which emit in the blue and are neither good for beast nor man or woman. And that's one of the professors of sleep physiology at one of the universities. Okay, so thank you very much for your attention. I don't know if there's time for questions. That piece of stained glass, that lovely piece of stained glass, came from the observatory of the Huggins Observatory in Tulse Hill in South London. That was one of the artifacts that still remain. There's about half a dozen of these bits of stained glass that were donated by his wife Margaret. After the observatory closed in 1914, she donated the stained glass to Wellesley Women's College in Boston, Massachusetts. So they've got the collection there. Thank you.
So, have you used an attic camera before?
Yes.
So how does the sensitivity of your new camera, that Starlight, and attic compare? So the new one is better or not?
I would have to look up the specifications, so I can't answer that question directly.
Yeah, I was just wondering, maybe you have, you compared your Spectra, taken with these two cameras.
Well, as far as I know, they use the same Sony chip.
I can confirm. Yeah, the Attic 4 XE and the camera you have now from Starlight Express are using the same sensor.
Yeah.
So they are camera.
So that would mean the sensitivities.
The quantum efficiency is the same. Almost all the parameters are the same.
I want to know.
I have a question about C14, the telescope. You have fan for cooling? You have a fan for cooling the primary mirror?
No.
How much it takes to cool down?
Well,
Because you have a lot of turbulence. Before you open the
I opened the roof early, an hour before the observing session, and that cools it down.
Because it surprised me. I thought the C14 has some fun to
That's an old C14, an old fast star. I'm not sure if the newer C14s have a fan. I forget what they call. I forget the Edge. They do the Edge series. There's been problems with the manufacture of the C11s and the C14s because there's been a supply problem with the glass, and their